Typically, with any piece of technology, you get out what you put in. Pump 1 unit of energy into an electric toaster, and you get about 1 out in the form of heat. That's just the first law of thermodynamics. Energy has to be conserved. But there's a piece of technology called a heat pump, where for every bit of energy you put in, you get 3 to 5 times as much heat out. What wizardry is this? Heat pumps have been hailed as a climate-friendly heating solution to traditional heaters, most of which operate by burning fossil fuels. So much so that in 2021, heating buildings was responsible for about 10% of global energy-related CO2 emissions. Heat pumps reduce emissions in 2 ways. First, they run on electricity, meaning less fossil fuel use as grids make the switch to renewable energy. And second, they're more efficient than their counterparts, using less energy to produce the same amount of heat. Where a typical oil or gas boiler is at best about 90% efficient, some heat pumps can achieve 500% efficiency. Heat pumps rely on the same technology as air conditioners. And in fact, they often double as air conditioners, heating your home in the winter and cooling it in the summer. How? Air conditioners take heat from your home and move it outside. To do so, they harness the second law of thermodynamics. That's the one that says that heat will always move from a hotter object to a colder one. When you turn on your AC, a fan blows the hot air from your home over coils containing a substance called a refrigerant. A refrigerant's molecules turn to gas at relatively low temperatures, so as it collects thermal energy from the hot air in your home, it boils. Then it passes into a compressor, which pushes the gas molecules closer together, heating them up even more. Now that gas is hot, way hotter than the outside air. So when a fan blows over the refrigerant, thermal energy transfers to the comparatively cold air outside. As the refrigerant releases heat, it starts to liquefy. It goes through an expansion valve, which decreases the pressure, causing it to get even colder. Now it's ready to pick up more heat from your house and start the cycle again. In winter, heat pumps work exactly the same way, but this time they pick up heat from outside and move it into your home. Of course, it's sometimes freezing outside when you want to use your heater, but the air doesn't need to be warm. It just needs to be warmer than the refrigerant to transfer its heat. All this sounds great, but for now, there are some drawbacks to this technology. First, refrigerants can be potent greenhouse gases. Hydrofluorocarbons are some of the most popular refrigerants, but a single hydrofluorocarbon molecule can have 2,000 times the global warming impact of CO2. While in use, the refrigerant stays contained in a closed loop. But when heat pumps, ACs, and refrigerators are improperly installed or thrown into landfills, the refrigerant can leak out. So scientists are trying to create new refrigerants that are better for the environment. Also, the colder it is outside, the less efficient an air-to-air heat pump will be. Nevertheless, over half of the buildings in icy Norway use heat pumps. Some people there have opted for pumps that draw heat from under the ground, which stays more consistently warm rather than heat from the air. Finally, there's the cost. In the US, installing a small heat pump usually costs several $1,000s, though some people need more powerful systems, depending on the size of their home or the temperature in winter. Often, they're only a little more expensive than installing a new AC system, and the heat pump can save money on utilities in the long run. But replacing a working system requires an upfront investment that a lot of people just don't have. Still, as the risks of climate change loom, many countries are offering subsidies to help with the costs. And some cities are creatively harnessing seas, sewage, and data centers as heat sources, using heat pumps in manufacturing, and even creating giant heat pumps for entire districts. So are heat pumps actually breaking the first law of thermodynamics? Of course not. They're just not using their electricity to make heat. They're using it to power the compressor and spin the fans. They get the extra energy for free, from heat in the air or underground, which is how by putting in 1 unit of energy, you get 3 to 5 units of heat out. Seems like magic, but it's just physics. Another seemingly magical technology, batteries. Find out what makes these essential devices work and keep working after being recharged with this video. And visit ed.ted.com/earthschool for an action guide that shows how you and your community can make a positive impact.